WHO really built the pyramids? Introduction. The eternal mystery. For over 4.5 millennia, the Great Pyramid of Giza has risen majestically from the sands of Egypt, a silent sentinel witnessing the passage of time. Towering at 146 meters and constructed from millions of massive limestone and granite blocks, it is more than a tomb. It is a statement to eternity, a testament to the ingenuity, vision, and determination of an ancient civilization. Imagine standing at the base of the pyramid. The sun beats down on the desert. The wind whispers across millennia. Each block tells a story of human ambition, of organization, of labor meticulously executed over decades. Every angle, every line, every chamber within the pyramid reflects precision that continues to astonish modern engineers. For centuries, historians and archaeologists have attempted to unravel the mystery: who really built the pyramids? How were they constructed with such meticulous precision? What knowledge did the ancient Egyptians possess that allowed them to achieve the impossible? The pyramids are more than architectural marvels. They are symbols of human aspiration, spiritual vision, and mathematical genius. Their story intertwines with astronomy, religion, politics, and the timeless quest for immortality. As we embark on this journey through time, it is important to remember that the answers are both known and unknown. Evidence from archaeology tells us much, yet many questions remain, whispering to us across the ages. If you want to delve deeper into history's greatest enigmas, don't forget to subscribe to Mindily and join us as we uncover secrets the sands of time have hidden. The land of Egypt, a civilization of the Nile. To understand the pyramids, one must first understand Egypt itself. Around 2700 BCE, during the Old Kingdom, Egypt was a flourishing civilization defined by the life-giving Nile River. Its annual floods deposited fertile soil across the desert, creating a landscape capable of sustaining a large population. The Nile was the artery of life, enabling agriculture, trade, and communication. Surrounding deserts provided natural barriers against invasions, creating a relatively secure environment in which civilization could thrive. The Egyptians developed a society that valued order, hierarchy, and permanence. Their worldview combined practical knowledge with spiritual philosophy. Pharaohs were considered divine rulers, living embodiments of gods on earth. Their power was absolute, yet it was exercised in conjunction with a bureaucracy of scribes, priests, architects, and artisans. Every major construction project, every religious ritual, and every political decision was orchestrated with precision and purpose. The early Egyptians built mastabas, flat-roofed, rectangular tombs for the elite. These structures were primarily made from mud brick, simple in form, yet symbolic in meaning. Over time, architects sought greater verticality and grandeur, culminating in the step pyramid of Djoser at Saqqara, the first major stone monument of its kind, designed by Imhotep, history's first known architect and polymath. The step pyramid represented a revolution in architecture. Unlike earlier mastabas, it was constructed from limestone, not mud brick. Each layer was stacked with increasing height, forming a step structure that symbolized ascension toward the heavens. The pyramid's design reflected a profound understanding of geometry, engineering, and the spiritual symbolism of life and death. Imhotep's innovations laid the groundwork for the pyramids of Giza. They inspired generations of builders, setting a standard of precision, planning, and aesthetic vision that would define ancient Egyptian architecture for centuries. The river, the desert, and the society. The Nile was more than a river, it was the lifeblood of Egyptian society. Seasonal flooding determined agricultural cycles, dictated labor availability, and influenced religious beliefs. Pharaohs and priests monitored the river, linking its rhythms to the divine order. The desert, often seen as barren, provided natural protection and building materials. Quarries along the Nile and nearby hills supplied limestone, granite, and sandstone essential for monumental construction. Transportation relied on barges and sleds, while knowledge of friction, leverage, and human coordination made it possible to move stones that weighed tens of tons. Egyptian society was organized meticulously. Laborers were divided into specialized teams: stone cutters, transport crews, masons, and architects. Each individual understood their role in the larger project, and records suggest a system of rotation that allowed thousands to work on monumental projects without exhausting resources. Cultural and religious beliefs were tightly intertwined with architecture. Tombs and temples were designed to mirror cosmic order, the journey of the soul, and the divine power of pharaohs. Mathematics, astronomy, and art converged to create a civilization capable of feats that still fascinate and confound modern observers. Pause for reflection. Imagine being a worker in that era, hauling massive stones, guided by master architects, contributing to a monument meant to last eternity. The human effort alone is staggering, but it is only part of the story. Remember to subscribe to Mindily as we continue exploring the mysteries of ancient Egypt. The Step Pyramid of Djoser and improvements in design. The Step Pyramid represents a turning point in Egyptian architecture. Unlike simple mastabas, it embodied vertical ambition and spiritual symbolism. Each layer represented an elevation toward the sky, a tangible metaphor for the pharaoh's ascension to the afterlife. Imhotep's genius lay not only in the use of stone but in the coordination of labor, geometry, and design principles. The precision achieved in the step pyramid set a precedent. Builders learned how to measure angles, align structures to cardinal points, and distribute weight across layers to ensure stability over centuries. The step pyramid also introduced enclosed courtyards, ceremonial passages, and chambers, foreshadowing the internal complexity of later pyramids. Its design demonstrated that the ancient Egyptians were not merely experimenting, they were perfecting techniques for monumental construction. The pyramid was a national project. Tens of thousands of workers participated in its construction, supported by agriculture, logistics, and administration. Evidence suggests that workers were well fed, housed, and respected, contradicting older assumptions that slaves built these monuments. Reflection and pause for the audience. As we consider the step pyramid, we must ask ourselves, how could humans, thousands of years ago, develop this level of architectural sophistication without modern tools? How much knowledge has been lost to history? These questions will recur as we explore the Great Pyramid of Giza, for it represents the pinnacle of Egyptian ingenuity and ambition. WHO really built the pyramids? Introduction to Khufu. Pharaoh Khufu, known to the Greeks as Cheops, ascended the throne around 2580 BCE during Egypt's 4th dynasty. His reign marked a period of stability, wealth, and unparalleled ambition. Khufu is most famously remembered for commissioning the Great Pyramid of Giza, a structure that would become the most iconic symbol of ancient Egypt and one of the greatest architectural achievements in human history. Unlike earlier pharaohs, Khufu desired a monument that would surpass all previous constructions, a pyramid not only larger than his predecessors' tombs but also built with unprecedented precision and scale. He envisioned a structure that would stand for eternity, a lasting testament to his power, his divinity, and the ingenuity of his civilization. The political and cultural context. To understand Khufu's ambition, we must examine the Egypt of the Old Kingdom. The Nile's abundance supported population growth, urban development, and specialization of labor. The pharaoh's authority was absolute, yet administration relied on a sophisticated bureaucracy that managed taxation, agriculture, labor, and monumental construction. Religion played a central role. Pharaohs were considered gods on earth, intermediaries between humans and the divine. Building a pyramid was not merely an act of vanity, it was a sacred duty, ensuring the cosmic order and the pharaoh's eternal life. The construction of a pyramid required coordination of engineering, labor, and resources at an unprecedented scale. Khufu's project would involve tens of thousands of workers, organized into crews, each responsible for specific tasks ranging from quarrying stones to transporting massive blocks along the Nile. Planning the Great Pyramid. Khufu's architects faced enormous challenges. The pyramid would rise over 146 meters, cover 13 acres, and consist of more than 2.3 million stone blocks. Achieving perfect alignment with the cardinal points and precise internal dimensions required advanced knowledge of geometry, surveying, and astronomy. The site at Giza was carefully chosen for its elevated plateau, stable bedrock, and proximity to the Nile. Quarrying limestone for the pyramid's core and high-quality Tura limestone for the outer casing demanded careful planning. Granite, quarried at Aswan nearly 800 kilometers away, would be transported via the Nile, requiring ingenious logistical solutions. Each stone had to be measured, cut, transported, and positioned with incredible precision. Even the largest blocks of granite in the king's chamber, weighing up to 80 tons, were maneuvered with tools of copper, wood, and ingenuity. Construction techniques and theories. Historians and engineers have long debated how the ancient Egyptians built the Great Pyramid. Multiple methods have been proposed: straight ramps, which would require enormous lengths of material, dragging stones to higher levels. Spiral ramps, wrapping around the pyramid as construction progressed, allowing continuous access to upper levels. Levers, sledges, and lubrication, potentially reducing friction to move massive stones. Internal ramp theories, suggesting hidden corridors within the pyramid facilitated stone placement. While no single method has been universally confirmed, experiments and simulations demonstrate that ancient Egyptians could have accomplished this feat using their available technology, with organization, labor, and ingenuity playing pivotal roles. The workforce behind the pyramid. Contrary to ancient myths, the pyramid was not built by slaves but by a skilled, organized workforce. Archaeological discoveries, including the workers' village at Giza, provide evidence. Large teams of laborers worked in rotation, ensuring sustainable construction schedules. Villages contained bakeries, breweries, sleeping quarters, and medical facilities. Graffiti on stones reveals pride in work and identifies crews responsible for sections of the pyramid. These findings illustrate a complex, well-managed society capable of executing massive projects, demonstrating that monumental construction is as much about social organization as it is about technical skill. Internal structure and chambers. The Great Pyramid contains a complex internal network of chambers and passageways. The King's Chamber, constructed entirely of granite, aligned precisely along the pyramid's central axis. The Queen's Chamber, with its unique air shafts, whose purpose remains partially mysterious. The Grand Gallery, an architectural marvel enabling precise stone placement and load distribution. Narrow corridors, hidden chambers, and ventilation shafts reveal advanced planning and engineering. Recent research by the Scan Pyramids project using muon tomography has uncovered previously unknown voids, suggesting that the pyramid's internal structure may still hold secrets waiting to be explored. Khufu's vision and legacy. Khufu's Great Pyramid was more than a tomb, it was a statement of power, divinity, and permanence. It symbolized Egypt's understanding of mathematics, astronomy, and engineering, while also embodying religious beliefs about the afterlife. It is a monument not only to Khufu but to human ambition, organization, and creativity. The construction required decades of planning, resource management, and the dedication of thousands of workers, all coordinated under the vision of a single ruler who sought immortality through stone. Pause for reflection. Imagine the dedication, labor, and knowledge required to construct such a structure. Every stone, every angle, every chamber reflects human ingenuity in its purest form. Subscribe to Mindily to continue exploring the greatest mysteries of history and uncover more secrets hidden in the sands of Egypt. WHO really built the pyramids? Introduction to Engineering Marvels. The Great Pyramid of Giza is more than a tomb, it is the culmination of centuries of architectural evolution and engineering mastery. To understand the scale of this achievement, one must consider the sheer logistics, precision, and knowledge required to move millions of stones, each weighing several tons, and place them with near-perfect alignment. Modern engineers have studied the pyramid extensively and continue to marvel at its sophistication. The base alone covers over 13 acres, aligned almost perfectly to the cardinal points with less than a fraction of a degree of error. The corners are precise right angles, and the foundation is level to within a few centimeters across more than 230 meters. But how was this possible for a civilization without steel, pulleys, or modern machinery? The answer lies in planning, mathematics, innovative tools, and human coordination. Materials and quarrying. The pyramid's core is primarily constructed from limestone blocks, quarried locally. The outer casing, originally smooth and reflective, used high-quality Tura limestone. The heaviest blocks, forming the King's Chamber, are granite, sourced from quarries in Aswan, more than 800 kilometers away. Moving these stones required careful planning. Transport involved barges along the Nile, sledges pulled over prepared paths, and perhaps even lubricated with water to reduce friction. Workers would have had to coordinate the loading, transport, and unloading of stones with extraordinary precision. Quarrying itself was an art. Copper chisels, dolerite hammers, and wooden wedges allowed artisans to cut stones into precise shapes. Each block was measured to exact dimensions, ensuring stability and alignment as the pyramid rose. Logistics and labor organization. The Great Pyramid required tens of thousands of workers, divided into specialized crews. Each team had its responsibilities: quarrying stones, transporting materials, constructing ramps, carving interior chambers, aligning the pyramid to astronomical and geometric specifications. Rotational labor systems ensured that workers were well rested and fed, with evidence of bakeries, breweries, and medical facilities near the pyramid. Graffiti on stones shows pride and identification of teams, indicating an organized and motivated workforce. The coordination of such a massive labor force reflects a society that was highly structured and efficient, capable of executing one of the greatest construction projects in human history. Construction techniques and ramp. Scholars have debated the exact methods of construction for centuries. Several theories have emerged: straight ramps extending hundreds of meters, gradually elevating the stones. Spiral ramps, built around the pyramid as it grew taller, allowing continuous work on upper levels. Internal ramps, hidden within the pyramid, discovered through structural analysis. Levers and sledges, possibly combined with lubrication using water or sand. Recent studies, including 3D modeling and experiments, suggest that a combination of these methods could have been employed, adapting as the pyramid rose. The logistics required careful timing and coordination, with engineers overseeing every phase of the project. The Grand Gallery and internal chambers. The internal structure of the Great Pyramid is a masterpiece of design. The Grand Gallery, a steeply inclined corridor, served both structural and functional purposes, allowing placement of massive granite beams. The King's Chamber, constructed from granite blocks, demonstrates remarkable precision in joining and alignment. The Queen's Chamber, whose purpose is still debated, features air shafts aligned with specific stars. Hidden corridors and voids, recently revealed by muon tomography, suggest that the pyramid still holds secrets unknown to modern archaeologists. Each chamber, corridor, and passage reflects not only engineering skill but also symbolic and spiritual significance. The placement of stones, orientation of shafts, and architectural design embody the Egyptians' understanding of the cosmos and the journey of the pharaoh's soul. Geometry, astronomy, and cosmic alignments. The Great Pyramid was designed with remarkable mathematical and astronomical knowledge, alignment to cardinal points with minimal deviation. Potential mirroring of Orion's belt, representing the pharaoh's journey to the stars. Proportions that encode knowledge of pi, the golden ratio, and advanced geometry. These features demonstrate that the pyramid was not merely a tomb but a cosmic instrument, designed to reflect the harmony between Earth, the heavens, and human endeavor. Archaeological evidence and modern discoveries. Ongoing projects, such as the Scan Pyramids project, continue to uncover hidden structures and voids. These discoveries suggest internal ramps or chambers yet unexplored, new insights into the methods of construction. The possibility of chambers serving ceremonial or structural purposes unknown to us. Archaeologists continue to debate theories, combining historical texts, archaeological evidence, and modern technology to reconstruct the methods used by ancient builders. Reflection and audience engagement. As we consider the engineering genius of the Great Pyramid, pause for a moment. Reflect on the human effort, the tens of thousands of workers, the architects planning each step, the precision required without modern tools. It is a reminder of what humanity can achieve when vision, organization, and determination align. Subscribe to Mindily to continue exploring these ancient mysteries, and join us as we uncover the hidden genius of our ancestors. WHO really built the pyramids? Introduction to the workforce. While the Great Pyramid of Giza towers majestically over the desert, its true story lies not only in stone but in the countless hands that built it. Tens of thousands of workers, craftsmen, and laborers formed the backbone of this monumental project, each playing a vital role in realizing Pharaoh Khufu's vision. For centuries, myths depicted the pyramid as the work of slaves, toiling under harsh conditions. Archaeological evidence, however, paints a different picture, one of skilled, organized, and well cared for workers, united by a common purpose and a deep sense of pride. The Workers' Village at Giza. Excavations at Giza reveal a fully functional workers' village, complete with bakeries, breweries, dormitories, and medical facilities. These discoveries indicate that the workforce was highly organized and sustained. Housing: workers lived in shared dormitories, constructed near the pyramid to minimize travel time and increase efficiency. Nutrition: large-scale bakeries and breweries produced bread and beer, staple foods providing calories and energy for grueling labor. Archaeological evidence even shows butchered meat, indicating protein-rich diets. Medical care: injuries were treated with care, skeletal remains show healed fractures, suggesting attentive medical assistance. Village also contains cemeteries for the workers, showing respect and recognition for their contribution. Graffiti found on stones proudly identified teams responsible for specific sections of construction, demonstrating camaraderie and accountability. Division of labor and specialization: the workforce was organized into specialized teams, each with a distinct role: stone cutters, quarrying and shaping blocks with copper tools, dolerite hammers, and wooden wedges. Transport crews, moving stones from quarries to the pyramid via sledges, barges, and prepared pathways. Masons and builders, placing blocks precisely, adjusting angles, and maintaining alignment. Surveyors and architects, ensuring geometric precision, alignment with cardinal points, and structural stability. Support staff, cooks, water carriers, medical personnel, and logisticians sustaining daily operations. Rotation systems allowed teams to work for months at a time, then rest while others took over. This system prevented exhaustion and maintained a high level of productivity and precision. Daily life of the worker's life for a pyramid worker was physically demanding yet structured. Morning, teams gathered early, often accompanied by chants or instructions from overseers. Labor, workers carried stones, erected ramps, cut blocks, and positioned them with incredible precision. Meals, large communal meals of bread, beer, onions, and occasionally meat sustained energy levels. Rest, dormitories and shaded areas allowed workers to recuperate before the next shift. Social life, graffiti, inscriptions, and markings indicate pride, humor, and camaraderie among crews. Despite the hardship, evidence suggests that workers were motivated and respected, contrasting sharply with earlier depictions of forced slave labor. Social hierarchy and organization. The Pyramid Project reflects a highly structured society. Pharaoh Khufu as the divine ruler, overseeing the grand vision. Architects and engineers directing construction and planning logistics. Skilled craftsmen leading teams and maintaining quality. Laborers executing tasks under precise instructions. Support personnel providing essential services to sustain the workforce. This hierarchy ensured coordination on an unprecedented scale, demonstrating the complexity of Old Kingdom administration. Religion, rituals, and spiritual motivation. Religion permeated every aspect of pyramid construction. Workers likely participated in rituals, invoking divine favor and ensuring alignment with cosmic order. Offerings, prayers, and ceremonial practices reinforced the spiritual significance of the pyramid. The act of building became a shared religious duty, connecting labor to the pharaoh's eternal journey. These spiritual motivations may have contributed to the pride and dedication evident in the workers' graffiti and inscriptions. A human story behind the stones. While the stones are monumental, the human stories embedded within the construction of the Great Pyramid are equally profound. Imagine the rhythm of daily labor echoing across the plateau. The meticulous attention to detail in every block. The pride of a crew leaving their mark on history, knowing that their work would last millennia. The pyramid is as much a testament to human organization, ingenuity, and spirit as it is to architectural brilliance. Pause for reflection. Consider the collective effort, coordination, and skill that brought this vision to life. It is a story of ordinary humans achieving the extraordinary. Subscribe to Mindily to continue uncovering the secrets of ancient Egypt and the true story of the pyramids. WHO really built the pyramids? Introduction to Symbolism. The Great Pyramid of Giza is not merely a tomb or an architectural marvel, it is a cosmic instrument, a monument designed to reflect the harmony between earth, the heavens, and human endeavor. Every stone, every chamber, every corridor embodies a profound understanding of the universe, mathematics, and spirituality. The Egyptians did not separate the physical from the spiritual. Architecture was intertwined with astronomy, religion, and symbolism. To them, the pyramid was a bridge between the terrestrial and celestial realms, a vessel for the pharaoh's journey to eternity. Subscribe to Mindily to continue exploring the hidden cosmic significance of history's greatest structures. Astronomical alignment. The pyramid's alignment with the cardinal points is extraordinary. The north-south axis is aligned within a fraction of a degree of true north. The east-west axis demonstrates similar precision, suggesting careful observation of the sun and stars. Researchers propose that the pyramid's builders may have used the circumpolar stars to achieve this alignment. Stars that never set, considered imperishable, symbolized eternity, a fitting guide for a pharaoh's eternal resting place. Moreover, the pyramid may mirror the Orion constellation, associated with Osiris, the god of the afterlife. This alignment suggests that the pharaoh's tomb was deliberately placed within a cosmic map, reflecting the Egyptians' belief in the connection between human rulers and the divine cosmos. Geometry and mathematical precision. The Great Pyramid's design reveals a sophisticated understanding of mathematics. Its proportions suggest knowledge of pi, with the relationship between the pyramid's perimeter and height approximating the constant. The golden ratio, phi, appears embedded in its geometry, reflecting an aesthetic principle of harmony. Dimensions are calculated with remarkable precision, ensuring structural stability over millennia. These features indicate that ancient Egyptians were not merely skilled laborers but mathematicians and astronomers, capable of integrating cosmic, religious, and structural knowledge into a single monumental design. Internal alignments and air shafts. Inside the pyramid, chambers are designed with astronomical intent. The king's chamber is aligned with precision to specific points in the sky. Air shafts in the queen's chamber point toward stars associated with spiritual journeys, including Sirius and Orion's belt. These features demonstrate that the pyramid was both a tomb and a celestial instrument, designed to guide the pharaoh's soul to the afterlife and ensure alignment with cosmic order. Spiritual symbolism: the pyramid embodies profound spiritual concepts. Its stepped layers represent ascension to the heavens. The internal chambers symbolize stages of the soul's journey. Orientation, materials, and design reflect Egyptian beliefs in life, death, and rebirth. Building the pyramid was not only an architectural achievement, it was a ritualized act of devotion, blending science, religion, and artistry into a singular statement of cosmic order. Cosmic calendar and solar alignments: recent studies suggest that the pyramid also functioned as a cosmic calendar. Solar observations may have guided construction phases and religious ceremonies. Seasonal shadows and sunlight entering specific chambers at key times may have held ceremonial significance. Alignments with solstices and equinoxes reflect the Egyptians' deep understanding of astronomy and natural cycles. These connections indicate that the pyramid was a multidimensional tool, tomb, temple, and celestial observatory, all in one. Reflection and audience engagement: consider the brilliance of this ancient design, a structure that has endured over 4,500 years, perfectly aligned with the stars, mathematically precise, and imbued with spiritual meaning. It forces us to ask, how did humans, thousands of years ago, integrate engineering, mathematics, astronomy, and religion into a single monumental project? How much of their knowledge has been lost to time? Pause for reflection. Imagine standing inside the Grand Gallery, looking up at the ascending stones, knowing that every alignment has purpose, every angle holds meaning. Subscribe to Mindily to continue this journey into the hidden knowledge of the ancient world. WHO Reintroduction to controversies: even after centuries of study, the Great Pyramid continues to spark debate and intrigue. Scholars, engineers, and archaeologists have analyzed every aspect of its construction, yet questions remain unanswered. From hidden chambers to unexplained precision, the pyramid challenges our understanding of ancient technology and human capability. These debates are not about myths of aliens or magic, but about the limits of Bronze Age engineering, logistics, and knowledge. How did the Egyptians achieve such feats with tools made of copper and stone? How were the largest granite blocks placed with incredible accuracy? Subscribe to Mindily to uncover more secrets hidden in the sands of Egypt. Hidden chambers and muon tomography: in recent years, cutting-edge technology has revealed astonishing discoveries inside the pyramid. Muon tomography, a technique using cosmic rays, detected previously unknown voids within the structure. These hidden spaces could indicate internal ramps, ceremonial chambers, or structural features yet unexplored. The discovery has reignited debates about construction methods, purpose, and design strategy. Despite thousands of years of research, the pyramid still guards secrets that challenge both scientists and historians. Controversial theories: several theories have been proposed, some more credible than others. Internal ramp theory suggests hidden corridors allowed placement of massive blocks, supported by structural analysis and some archaeological evidence. Lost techniques: ancient Egyptians may have used construction methods now forgotten, combining ingenuity with practical physics. Speculative theories: some propose extraterrestrial assistance or advanced prehistorical knowledge. While not supported by evidence, these ideas highlight the pyramid's enigmatic perfection. Archaeologists like Zahi Hawass emphasize evidence-based methods, while engineers recreate techniques using sledges, ramps, and manpower experiments, showing that human skill alone could account for the construction. Logistics and engineering debates: the scale of the pyramid continues to baffle experts. The tens of thousands of workers had to be coordinated precisely over decades. Stone transportation over hundreds of kilometers required innovation, likely involving Nile barges and sledges lubricated with water or sand. The placement of granite blocks weighing 80 tons in the king's chamber demonstrates remarkable mastery of physics and leverage. While modern experiments show it is technically feasible, the question remains: how did they organize and execute such a complex project without written engineering manuals? Archaeological evidence supporting human achievement: excavations at Giza reveal compelling evidence of human ingenuity. Workers' villages with bakeries, breweries, dormitories, and medical facilities. Graffiti on stones showing pride and team identification. Tools: copper chisels, dolerite hammers, and wooden sledges consistent with experimental reconstruction of pyramid construction. These findings confirm that the pyramid was built by highly skilled humans, not by slaves or mythological forces, yet the sophistication still leaves room for wonder. Unsolved mysteries: despite centuries of research, several mysteries remain. Precision: how did they achieve near-perfect cardinal alignment without modern instruments? Hidden structures: What lies in the voids discovered by muon tomography? Astronomical alignments. Are there undiscovered celestial connections embedded in the pyramid's design? Construction secrets. Were there techniques that have been lost to time, making reconstruction today an incomplete science? These questions ensure that the Great Pyramid remains not just a monument of stone, but a monument of human curiosity, challenging us to explore, imagine, and seek knowledge. Reflection and audience engagement. As we reflect on these mysteries, we are reminded that history is a living puzzle. The pyramids stand as silent witnesses, inviting us to question, learn, and marvel at the ingenuity of our ancestors. Imagine walking through the Great Pyramid today, considering the thousands of hands that built it, the precision of every block, and the mysteries still hidden within. This is more than architecture, it is human ambition carved in stone. Subscribe to Mindily to continue exploring humanity's greatest mysteries, uncovering the secrets of our past, and connecting with stories that inspire wonder and reflection.